Hey guys, so in the last video, I introduced this word density and then talked about mass and weight. So a weight comes up when you have a mass that has gravity applied to it. So right now we're going to look at what that means for density. And to do that, let's bring in this beaker of tortilla chips. Okay. First, let's make a measurement just to find out how much tortilla chips we actually have. You know, sometimes you have extra chips at home and they go stale, so you don't want to eat them, so use them for science. So we have around maybe 220 or so-ish milliliters of chips. Okay. So I'm going to use this whiteboard to keep track of my data as we go through this. Beaker, maybe it's like 220 or so. So we'll say volume, this is beginning or before. Volume before equals like 220 milliliters. Now, let's also find what the mass is. Or sorry, we're going to measure the mass by taking the weight. We do have a scale right here. So the mass, we will call it, I already teared this scale, so I already zeroed the scale. So I'm going to put this on the scale. So this mass should not include the mass of the beaker. And so we have around 42.8 grams of chips. Okay, it's 42.8 grams of chips. And then after what, you might be saying? We're still going to have a beaker. But before we do that, we're going to take a little setup here. I'm going to take this beaker of chips and put it into this bag. Make sure it's all in there. And then, you can see it. And then, just gonna smash it in. Oh no! There we go. I'm gonna smash the chips. Da-na-na-na. There we go. That's pretty good. I didn't realize that smashing chips would be so destructive. So now let's take these chips and put them back into the beaker. And we're going to measure the volume of the chips again. So we did lose some of the chips in transit, in the smashing process, but it's still most of the chips. You'll see, there's just like a little bit of chips that kind of came out, so they're mostly still there. But the volume drastically changed. Okay, so now instead of having 220, we have like 110, maybe, if the camera is actually level with the line here. About 110. So let's write that on our board. Get that in here. Okay, so about 110, this is volume after. Now you know what happened before and after, right? After. Volume after, about 110 milliliters. And mass is going to be, put it back in the scale. What do we have? 41.9. Mass after. 41.9 grams. Okay, so what just happened, now if we draw this looks significantly different, right? This is more around 220. This is more around 110. So the mass is pretty much the same. We lost like 0.9 of a gram. So maybe that's like 2% of the total mass that was there. But the volume changed by 50%, right? So volume before is 100%, actually. It's twice as big as volume after. But you took 220, cut it in half to get 110. So what changed, right? The volume changed. And if we're looking at density, think of density as how much chip, or how much chip matter you fit into a certain volume. So we write density, D equals M over V. So mass over volume. And what that means is how much mass fits into a certain volume. Okay? So in this case, now we can figure out density. Okay, density before is going to be one value. Density after is going to equal another value. And we can do that math, but intuitively you can kind of also think, man, if D equals M over V, then we're going to have 220 over 42.8 over, let's call it like 43. And maybe for right now, I'm just going to round so that you get the ballpark idea. So 220 over 40, cross out some zeros, 22 over 4, it's like 11 over 2, which is like 5.5. And then we'll round over here again as well. So density, oh, I did that backwards. Let's go back. I need to continue this video because I already just smashed the chips, so I just need to go back and do this again. So density of before is 40, roughly, right? 40 over 220. So if we cross out the zeros, 4 over 22, simplify that, 2 over 11. So we have 2 over 11. Let's just leave it there for now. Density of A is going to be around 40, again, roughly. But our volume now, volume after, again, mass over volume, right, is 110. And I would write units, and you're supposed to write units, but I just want to I want you to see what happens with the magnitude of these numbers. So 40 over 110, you can cross out the zeros, so you have 4 over 11. And so this, afterwards, the chips are 2 times as dense, right? This density, 4 over 11, is twice as big as this density, 2 over 11. So if we're talking about chips, right here, we're thinking of density as the amount of matter, the amount of stuff that fits into a certain volume. And in this case, when the volume was up here, the reason why the volume was up there was because a lot of that volume actually was air, right? In this case, there's just less air mixed in with these chips, and so more of the 100 milliliters right here is actually chip matter. But the weight is still the same because the air inside of the speaker is not contributing really to the mass that shows up on the scale. So at this point, try and take this example and apply it to another situation. Like, for example, if you had 2 equivalent pieces of gold that had different shapes, right? If you had one piece of gold, it's still gold. And so the atoms in the gold are still packed together at the same level of compactedness. Is that a word? Compactedness? But it's the same level of compactedness as another sample of gold, because it's still gold, right? And so they should both have the same density, those 2 pieces. So any material, if you have the same substance, like aluminum, copper, if you take any substance and you just take smaller and smaller pieces of it, each piece should have the same density, okay? No matter how much you have of that substance. The volumes might change, and the mass might change, but the density should stay the same. So that's it.